All right, we're live. We're on the stream now. Yeah.
All right. Well, I want to welcome everyone here to JaxDug, our first meeting of 2021. It's been a little slow start. Thanks to Jeffrey to come on and present on DevOps. One of those things I think everybody can always learn from. I know I have to adjust and adapt almost weekly, if not daily sometimes, to what's going on with that. So if anyone has any questions, post in the comments there. We'll see them. We'll respond to you. If you have any issues, you can email me or hit me up on Meetup if that doesn't work either. All right, Jeffrey, why don't you go take it away?
Awesome. Well, thanks for having me. I appreciate it. This is fun. And I love the setup that you guys have and the software that you're using is very professional. So that's awesome. That's awesome. My name is Jeffrey Palermo, and I've been developing professionally since 1997. And it's almost exclusively been on the Microsoft platform. So I've gone really deep into there and done a small amount of Java on the side and other things, but really have been able to ride this Microsoft train for well over 20 years. And the tooling has been consistently outstanding. So if you, I know over the last 7 years, the number of developers in our industry has doubled. So if you're one of those in the 50th percentile and thinking about, a few decades forward in your career, the Microsoft platform definitely doesn't seem to be slowing down anytime soon from what it has been. So you can be glad that you've jumped on this train. We're going to be talking about Azure DevOps for .NET and specifically just the rules of thumb that enables you to fall into the pit of success. And a lot of these can be found in my latest book, .NET DevOps for Azure, and you can find that anywhere where the books are sold, print books are sold. But one agreement that I do have with the publisher, anyone who I kind of talk to directly here, present these user groups, if you will send me an email, I would be happy to get you a digital copy of the book. Because I really, you don't write books to make money, because it doesn't work that way, especially in the tech space. It's really to help people learn. So I just wanted to throw that out there. I've also been a Microsoft MVP since 2006, and I'm a chief architect at ClearMeasure, which is a software architecture company that helps .NET development teams kind of be able to be more effective and do more internally. A little bit about myself, just personally. I kind of get my monthly exercise in the amateur dirt bike racing scene, and not particularly good or fast, but it's fun. You can see me way back in the pack. Definitely not running out front. But my boy and actually my two daughters are also in the dirt bike racing scene, and we kind of live to the west of Austin, Texas, just past the suburb towns and off where we can have a little bit of land to do just small bits of livestock and just play around with it, and with some grazing the neighbor's cows and then having some chickens and some space there. All right, so today's session, we're going to be talking about the challenges of DevOps and looking at the structure that you need with your pipeline, and then really how to get started. So I mentioned before, if you want to do a screenshot of this screen, it has my email address on it. I already mentioned my book. Be happy to give you a free electronic copy. So Jeffrey@clear-measure.com. And also I'm the host of a podcast. It's called the Azure DevOps Podcast. And I mean, if you just search for Azure, this is in the top 5. Certainly searching for DevOps, it's kind of in the top of the list as well. And it's all about shipping software. So that's what that podcast is about, all the different types of software you can work on the Microsoft platform. And then there's a new video show that you might be interested in, architecttips.clearmeasure.com. It's just a 5-minute short tips. So the 7 key elements of a DevOps environment are right here on the screen. We need to make some design decisions. We need to structure our source control in a certain way, because the source control, that is the headwaters of the DevOps pipeline, which the analogy is water. It's pipeline. So your version control structure, that's where it all starts. Then we have some builds. We need to do various types of testing, including full system testing. Then we need to do manual testing, which is user experience testing, I like to call it. And then we actually need to release to production and then observe the system. And I call that telemetry observation. We need to gather telemetry and make sure that the software is doing what we expect it to do, and that the users of our software are doing what we expect it to do. So I like the word pipeline, and I think that it's a really good word because it invokes the analogy of water. And if you think about water, there's certain things that we need. If you turn on the faucet in your house, there's certain things that you need in order to be satisfied with the experience. One, when you turn on the water, when you're ready for water, the water needs to be there. And also the water pressure needs to be at the right level and consistent. If you turn it on and it's just drip, 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 well, that's not good. And if you turn it on and it's blowing you away like a fire hose, well, that's not good either. Or if you turn it on and then some comes out and it stops, and then some comes out and it stops. Also, we need quality. If we turn on the faucet and the water is brown, then that's not going to work for us. If we turn on the water and it's clear and then it's brown, it's clear and then it's brown, that doesn't work either. And it's a fallacy to think that we could accept brown water from, say, the city, or accept brown water from our own water well, and then in the house, right behind the faucet where we turn it on, we have this uber mega filter that's somehow going to remove all the impurities, and we just let it be brown in all the pipes. But by golly, we're going to clean it up right before it comes out of the faucet. That doesn't work either. We know from water pipelines that you have to keep the water clean in every part of the pipe. And every time you move it forward to a different location, it needs to be tested and treated and filtered and cleaned. So all of those transfer over to your DevOps pipeline. And again, your source control is the headwaters. So think about those concepts as you think about your pipeline. Every time you move it forward to a next stage, you need to have filters, which are essentially quality controls. You need to have some type of thing that you're doing that makes sure that the software is good and stable and is not dirty water. Also, whenever the customers are ready for the next release, and they turn on that spigot and say, hey, I'm ready, we need to be ready as a software. These are the things that make a difference from being a group of developers and being a development team and being an engineering team, because these are the things that bring engineering discipline to shipping software. And that's what we want to do. If we continue to think that software is an art where, oh, if I say it's good, it's good, or software is a craft where only I can do it, we're holding ourselves back. The more we need to deliver as a team, the more we need to adopt engineering disciplines and raise up the profession. So I love this analogy. Now, this here on the screen is a sample architecture of a DevOps environment. And this is actually the top third of a larger architecture poster that, by the way, if any of you would like the high resolution version, send me an email. I'll be happy to send it over to you. But this is a architecture poster for, and it's in the book as well, for the structure of a DevOps environment using the Microsoft stack. So Azure pipelines, Octopus Deploy is really popular, integrated with Azure pipelines, Redgate for SQL Server. And there's a minimum number of things that you need in your DevOps environment. And this kind of annotates every little thing. Now I'm going to cover a lot of this as we go through, but it kind of puts it in it's a highly shrunken technical blueprint for the structure and flow of a pipeline that at its core is Azure DevOps Services. And by the way, Azure DevOps Services is great as a foundation, but I'll say right off the bat, it doesn't do everything that you need. And so as you get more complex, for example, a lot of teams add on Octopus Deploy for the complex deployment environments. Or as the databases grow beyond your free and open source database migrations tool like Roundhouse or AliSQL, then they'll sometimes graduate to the Redgate products, which have fantastic support, or layer on the Redgate products for test database restore on demand for manual test environment deployments and things like that. So Azure DevOps, that is your nucleus, that's your core, your orchestration, but you are going to add products to it. So if you find yourself struggling where, oh, why can't I do this? Why can't I do that? Well, it may be an area of the product that is not just going to be fully featured like you need it to be, but there's other products that are complementary. All right, so let's get into the pre-code design process as one of the 7 elements that we need to think about. And so think about in your mind, think about Azure boards. Okay, this is tracking your work, Azure boards. Now we need a process. So the first 4 steps of this process at the top, those are design decisions that we need to make. The second 3 are specifically developer coding tasks where I'm going to type some code. We're going to do a build. We're going to, and then we're going to get it to the point where I have a deployable package in the appropriate format that's ready to go to an environment. And then the bottom is a progression of environments, a progression of deployments, where remember, every time we move forward, we have to have a quality check to make sure that we're not introducing a bug, introducing a problem. And so this is the way that I want you to think about this process as you create it for yourself in Azure boards. I want you to think about it as a state machine pattern. And you have an issue or a card, story card, a product backlog item, whatever you call it. You have a particular card issue in its simplest form, and you have a series of states. Now, in order to transition between the states, you need some activity to happen. You need a person or a role that is responsible and capable of performing that activity. And that's essentially a state machine pattern. So conceptual definition is figuring out what the heck this is, why are we doing it, the beginning of requirements. And by the way, the first 4, all of those make up the old term requirements, okay? So conceptual definition, why are we doing this? What's the general concept? UX design is how is a human going to use this? How is a human going to experience this? And if it has a visual element, then obviously you're going to have a wireframe, a picture of a screen of some sort. Or if it's just a change in behavior and moving data where there's no change to the visual interface, then the only change to the human experience may be, hey, can I count on new data coming every 30 minutes? Or does this really need to be a real-time feed of data? Even if it's not visual with the eyes, it's still part of how a human is going to experience or know or see any difference here. Technical design is where you make the decision of, do we need any additional architectural elements introduced to the software or design patterns, or do I need a new library or online service? Any technical decisions that need to be made in order for any developer to know what to do. And then after that, it's test scenarios. Scrum had a concept of acceptance tests or definition of done, and that all is absolutely appropriate here. But every feature or every change to the software always has a happy path and an exception path. So there's at least 2 test scenarios, and oftentimes there's multiple ways to go through the software. That's what that is. If you don't make those design decisions, then based on the personalities and differences of which developer happens to grab the issue, you're gonna have different results. But either way, these are states, and of course, after development, you have the functional validation at the team level, then the user experience validation at the, say, product management level, and then release validation, which is again back in the release management or technical level, getting it out to production, and then it's done. And the person that's qualified to take a state from one to the next is also qualified to evaluate whether it's ready or if any dependencies haven't been met, and then can revert it back to the previous state. That's the quality control check. So map this out to your Kanban board, and then in Azure Boards, you should have something that looks kind of like this. Now, I understand that the process templates in there kind of give you things like not started, in progress, and done. And really the not started is kind of off to the left of the screen here. And the done is the last column. So we have 8 different descriptions for in progress. Now, you could just lump it all into one and say, oh, it's still in progress. But as your team gets larger, and probably larger than, say, 3 people, somebody's going to ask, hey, why is this taking so long? And we have seen time and time again things that are, everybody else thinks that they're in development and actively being worked on, but really we found that there is a technical design decision that is being worked through or hasn't been done, or that part of the user experience is still being discussed. But because we didn't have granularity on those different decisions and those different activities, from the outside, all we knew was this amorphous, oh, it's in progress, but we didn't actually know what type of decision or activity was holding it up. So it's important to craft your own process for your team so that the distinct activities are called out with some sort of name. And again, I don't care what you call these columns at the top. Just make sure you have every concept represented. So that's how you lay out Azure boards to track your work. And the most important, I find the most efficient is the statuses ahead of development. We find that once you have some working code and you're going through tests, a lot of people have developed those statuses after the column that represents hands-on keyboard coding and actually typing. But the design decisions ahead of development tend to be left off pretty often. Now, the next bit is source control structure. So this is the architecture of your source control and your team and your applications. These are the general rules of thumb. Now, Azure Repos is fantastic for hosting source control, and it's full Git, and a lot of you are probably already using it. But there are some rules, and if you don't follow the rules, then you're just going to cause unnecessary pain. For example, a lot of you work on significant software systems, and you may have been divided into multiple teams. If you try to have 2 teams commit code to the same Git repository, then you're going to cause yourself pain. And so you want to make sure that one team owns a repository. Now, it can own multiple repositories, that's just fine. But it needs to really own that repository and not have commits being made by other teams. And a software system may be segmented and decomposed into multiple versioned software applications, but every versioned software application needs to have a dedicated Git repository. And now, by the way, it's perfectly fine for one versioned software application to have multiple processes. For instance, a web application and a SQL Server database and a couple of offline jobs. Those are all different processes that have to be deployed, but they're a part of one versioned software application. Now, if you are adopting some microservices elements and you want to factor off one of the offline jobs and make it an autonomous service where it owns its own data and it communicates back on published contracts, well, you're going to refactor out the entirety of that code, and it's going to have its own Git repository and its own independent versioning because you've made it truly an autonomous microservice. That's really the essence of a microservice on the source control side. And every Git repository starts a build and deploy pipeline in Azure DevOps. So every Git repository has one software build configuration. When you have a build, you build everything in that Git repository, and you create a release candidate with that, and then you deploy that. And so if some of you I know are out there thinking, well, wait a minute, no, we currently build We currently build just part of the Git repository, and we take only one piece of it, and then we build. Well, you also might be wondering, why has this thing gotten so complicated, and why do we fight with the tooling? That's why. So you need one Git repository, which has one version software application, which has one software build configuration. You build everything that's in that Git repository and produce a release candidate, and then you deploy it downstream to the different environments. And we'll talk about testing in each of these stages as well. There is a concept that's constantly represented in your DevOps pipeline, and that is the concept of a test. Now, some of you are very familiar with test-driven development. And so the concept of a test, you've heard arrange, act, assert. So just think of a unit test. There are steps that you do to arrange things to be prepared in order to conduct the test and exercise the system under test. And then the act. The act is actually doing it, calling the right method, executing it. And then after that, there's multiple things that you do to execute assert statements, to check to make sure that the right thing happened. Well, that's the concept of a test. So think of the test as an abstract concept, and even a C# interface, I test, okay? It has multiple things to do to set up and get ready, arrange, one thing in order to do it, and then multiple things to check to make sure that the right things happened, all right? Now let's evaluate that and apply that to our builds. Well, every pipeline is going to have two build configurations. You have your private build and you have your integration build. And I'm going to go pretty fast. So if some of these things you don't quite catch, refer back to the 2006 book titled Continuous Integration. It was the seminal book that defined the practice of continuous integration. And there are three key steps. You have your private build, which happens on a developer workstation to answer the question, can I share this code with my team, or have I destabilized the source code? That's your private build. It runs locally, completely locally. Then the integration build is on a shared build server. Of course, Azure DevOps provides those shared build servers. And it answers the question, is this code now mixed and mingled with code from other team members still stable and ready to be deployed to an environment, or is this code mixed with the other team members now unstable and we need to fix it? Okay, so those are the two builds. The third step of continuous integration is the first deployment. And that answers the question, does this release candidate, which is the product of the build, and oftentimes we say, does this build as a noun still deploy, start up, and generally work like it should? Because if it doesn't, well, we've destabilized something and there's no purpose to even deploy to a manual test environment and waste a human's time. Okay, so those are the three stages of continuous integration that go all the way back 15 years ago when continuous integration was first created. And I do encounter quite a number of teams, because of the tools and the products out there, that they'll say, "Oh, we have CI in place, but we don't have CD. We don't have continuous delivery," which is now somehow a synonym of just deployments. And then we'll look at what they have, and they have an automatically triggered compile process, but they thought that they had, quote, CI. So I just want to stress that continuous integration has three key steps, and you need all three: the private build, integration build, and your first deployment. Okay, if you have those three steps in place, well, then yes, you have continuous integration. Then you can, of course, go on to deploying to test environments and staging and production and whatnot. But think of this concept of I test, the abstract test. Your private build is a test. There's things that you do to set up and get ready to go. The act is actually transitioning from source code to executable artifacts, which is compilation. So you're running msbuild.exe on .NET Framework and running .NET.exe on .NET 5, .NET Core. And then the assert statements are multiple. If you have a unit test suite, great. That's one thing you do to check to see if, hey, are things going well? An integration test suite is another assert in the private build. If you have a static code analysis, and same thing with the integration build. So you need those things. Now, if we can map it out and look at the steps, in the arrange column, we definitely have to clean up temporary files and things of previous runs. We need to stamp a version number on what we're going to build. We need to create our SQL Server database, which, there's some software types that don't have a database, but by and large, when we work with .NET development teams, applications always have a SQL Server database, even if they have document database or any other kind of data stores and files and blobs and everything. Every one of them still have a SQL Server database, and so now with microservices, yeah, you could have one autonomous service that only operates on a queue and then does some other things. And in those cases, yeah, of course, no SQL Server database. That piece of software is pretty small, but setting up the data store would be setting up a queue with which to run some tests for that software. In the act column, it's compilation. In the assert column, unit test, integration tests, and then you would do essentially a test teardown or finish out on the build server. Now, static code analysis, as you mature, that really should be an assert. So, but if you're just getting started with static code analysis, sometimes you'll say, we can't fail it just yet because we're still learning what rule sets we need. And that's fine. Okay, so at the end of the build, we need to package our release. And if you have an application that has a web application, an offline job, SQL Server database, and then a full system acceptance test suite, then you have 4 things that are going to need to be deployed to the TDD environment, which I'll talk about in a minute. You have 4 things that need to be deployed. So you have a release candidate that is made up of 4 files. And the NuGet package is the format of your releasable artifact, the artifact that is stored in the Azure Artifacts service. In Azure pipelines, there is the old style drop method of storing build artifacts. And that came about before the Azure Artifacts product was online with a built-in NuGet server. And so if you're starting a configuration now, just ignore the built-in build artifacts. And for every deployable process in your application, package that up as a NuGet package and store it in Azure Artifacts. Now you can use a built-in tooling. You can use NuGet command line, but what I love to do is use the open source tool Octopack, which is actually a wrapper around the NuGet command line, and it simplifies the command line experience of zipping up everything you need to in an artifact. Literally, you can call .NET.exe publish on a particular project, and then the resulting directory you call Octopack on that directory, octopack.exe on that directory, and it takes everything and packages it up in a NuGet package, perfectly ready to deploy. But because NuGet, the actual NuGet format, was originally created for sharing libraries and that are dependencies in an application, it just has a few idiosyncrasies that you have to deal with, whereas Octopack deals with those idiosyncrasies for you and creates NuGet packages when the purpose of that is for deployment. Now, some people say, well, wait a minute, what if I'm planning on deploying it as a Docker container? In those cases, that the Docker container, and this is just speculative, by the way, the Docker container, if the deployment is a Docker host, the actual package may end up being your Docker container. All right, so you need 4. All right, in this example that I'm showing on the screen, you need 4, 1 for each independently deployable process. And I'll talk about the test suite later. All right, here is the dependency diagrams of the different environments. Now, I haven't talked about the environments yet. We have the TDD environment, the UAT environment, and the production environment. These are categories of environments. Every DevOps pipeline will have a minimum of 3 environments. Okay, so as you configure your release manager, or if you use the new YAML style multi-stage in Azure pipelines, you need at least 3 environments to deploy to. And let's just walk backwards. Production is a category of environment. To start out with, you may only have 1 production environment, but a lot of people have multiple production environments. But production is a category. Let's take Salesforce or Skype. They don't have just 1 production environment. There's multiple production environments. Heck, Azure has over a dozen production environments now. Every region is a production environment. Now, every region is implemented as a cluster. So here in Austin, Texas, if I choose South Central in order to be in San Antonio, then essentially I'm choosing the San Antonio production environment. But I know under the covers, there are 2 different buildings that make up South Central because of the redundancy. That is the clustering at the data center level. So you still have those concepts represented, but need at least one production environment. Let's walk back from there. Manual testing, UAT. Manual testing is a category. We need to have at least one environment where people can manually test. And UAT is a really common user acceptance test. That's a really common name for a manual test environment. We need at least one environment. Now, in a lot of organizations, you need to parallelize that as well. You need multiple. Common names for manual test environments are dev, test, sit, dit, staging, any number of names. And you can choose to deploy to all of them at the same time, or you can stage a few in a row, but they are all manual test environments, and you can have as many as you want, but you need at least one. If you don't have one, you can't do manual testing, okay? Pull back from manual testing environment, and now we have our test automation environment. This is the environment that fulfills the last stage of continuous integration that answers the question, will this build even deploy? Will this build even start up properly on this configuration? And will this pass our full system test? Will it generally work? And you need at least one of those. The most common name for that is the TDD environment. It stands for test-driven development. No humans are allowed on this environment. It doesn't make any sense. The build's just going to automatically deploy, run the tests, kind of throw it away. And so it's perfect for infrastructure as code in Azure because it can just create the environment, use the environment, throw the environment away. So it's very, very cheap. But you need at least one of those for the functional full system tests. If it's web, you're going to be using Selenium, but whatever you happen to use, whatever tests have to actually be run on a fully deployed instance of the software. Things that can't be tested in a build environment where you're just kind of running off disk. And you need at least one of those. Now, if you're going to run endurance tests that run the software for 7 days straight to check for memory leaks, or if you're going to do some security penetration testing, if you have other types of test suite, you know what? Maybe you need more than one test automation environment. That's particularly fine, but you need at least one. Okay. This is what the simplest pipeline is going to look like. And let me give you a little commentary because I want you to fall into the pit of success with Azure DevOps. About a year and a half ago, the YAML support came out for Azure pipelines, and V1 was there, and we had some plans, some enhancements for V2 and V3. There was going to be designer support, and Azure Release Manager, as you see on the screen, was going to be brought over into the fold. Subsequent to that, a lot of key people left and went to GitHub, and so the roadmap materially changed. And here we are a year and a half later, and we have a V1 implementation, or really a half implementation of the YAML configuration for your builds. And a lot of people are thinking, man, why don't I understand this? Why is it so hard? Why for some of these steps I have to insert a magic GUID in the YAML? And then other teams are saying, really, I just prefer using the designer. And then people will say, no, you need to store your build configuration in the Git repository. We need to be using YAML. And we have a half implementation right now. So it can be a little bit stressful because, yes, we would love to have the advantages of storing the build configurations in the same Git repository as our application. But if we give up the designer, well, then we lose our discoverability of steps. New people come on and they look at it and they don't even know what they're looking at, and it's hard to maintain. And some of the steps converted from the designers don't have good syntax. For example, pushing a package to Azure Artifacts, you have to know the GUID identifier of the Azure Artifacts feed in order to put that. There's no friendly name, and there's other steps like that as well. And so you have to kind of remember which GUID to copy and paste in there, which means that you end up having to have the version of the build configuration in the designer format and the YAML version kept in sync, just so that you can have a hope of editing it and changing it. So to fall into the pit of success, unfortunately, I still recommend using the designer version. You're not getting the benefit of being able to branch your build configurations like you would if you stored your build configuration in source control. But given that we're still waiting on some of the critical enhancements to the YAML version, unfortunately, that's what we still recommend. And I don't want you fighting with the tool. I want you to get down the road and be able to move fast. So that's what I find myself still recommending. Now, for people who've reached expert level with Azure DevOps, you don't need a recommendation from me. If you are already at expert level in Azure DevOps and you're slinging YAML and the downsides don't faze you, then by all means, you make your own decision. But for people who really are asking for that recommendation from me, that's the recommendation that I give. Because the designer scenario, it works and it's simple. And I'll show you an example a little bit later. All right, let's get into the environments. So we have this concept of a abstract test. Well, your TDD environment is an implementation of a test. Your manual test environment, UAT, is an implementation of a test. Your production environment is an implementation of a test. Let me tell you why. The TDD environment, your test automation environment, we're going to do some setup. We're going to configure the environment. We're actually going to deploy. That's our act. And the asserts are the acceptance test suite to make sure that everything goes well. In our manual test environment, we're going to have the same setup. It's going to be a little bit different because we're not going to load data on every deployment, but the assert is done by humans. The assert is done by a person that comes in and either gives their thumbs up or they say, nope, something's wrong with it, and they log a bug. Same thing with production. Now we could think, oh, when we deploy to production, then we're done. But that's not the case. Everyone here probably remembers the scientific method. And the most important part in the scientific method is the realization that the process of science can't actually prove anything and can't actually make any definitive statements. But it is a process of experimentation so that we can disprove our wrong guesses. Why? Because the scientific method starts with a hypothesis. Okay? We, from our judgment and our past experience, we make a guess at the answer to some question. Then we craft an experiment that says, okay, if my guess is right, then some other scenario will be true. And we craft an experiment, which is essentially an assert statement. And if that doesn't come out to be true, well, guess what? Our hypothesis was wrong. And if we do enough experiments and enough tests of our hypothesis, well, then other people start to believe that our hypothesis just might be true. We still can't say it definitively is true, but we've done enough experiments that other people believe in the experiments that we've done. And so we come to an understanding, and that's how hypotheses become theories and theories become laws. Okay. Same thing with software architecture. Software in general. We want to accomplish something in the marketplace. And so product management, of course, is thinking, how could we do that? What if we changed the software like this? And what if we had it do that? And then in the technical design, we're, okay, I understand that. Well, how are we going to do that? Let's use this library and that design pattern and integrate with this web service and all this stuff. Well, we deploy to production. That is actually the conducting of an experiment. And so that is when we need to start collecting telemetry from how our users are using the software to see if our hypothesis is correct, because it might not be. There were some studies and surveys just a couple of years ago that looked at the effectiveness of Scrum's product owner role. And what the study found was that, and Sam Guggenheimer actually participated in the study, and he kind of turned me on to this. He was a guest on the Azure DevOps podcast a couple of years back. And he said that what the study found was that a third of the time, what the product owner said we should do was spot on. A third of the time, it got the desired effect out in the marketplace with the users, and it was awesome. A third of the time, we did the software, we put it out there, it had absolutely no effect on the problem whatsoever. We invested the time, we did the development, it had no effect on what we were trying to accomplish. And then a third of the time we did it, and it did the opposite of what we wanted. It was actually destructive. It fought against us from what we were trying to accomplish. And we need to roll it back and get that out of there, okay? So the concept of a person, product owner in that Scrum process, somehow being the ultimate subject matter expert, no one can be, okay? So we need to recognize that what we are doing, all those issue cards that pop up on our board, those are hypotheses. Those are, hey, this would be a good thing to do, and it would help us accomplish a goal. But when we get to production, if we don't gather telemetry intentionally and funnel that back, then we have no ability to finish the test, which is assert statements. Did users start using the software more? Did lost passwords go down? Did revenue go up? Did sales go up? Did shopping cart completions go up? Whatever you're trying to accomplish. All right, so let's dive into what a deployment to the TDD environment looks like. And there is a pattern that emerges. And if you have pages and pages of steps in your Azure DevOps configuration, then you're not using the tool like it's intended to be. There is a clear pattern that you go through, and this particular one has 3 iterations. Okay, there are 3 things that are being done here, and you can see the pattern. I'm going to skip the first step right now. So look at the step obtain database package. These first 4 steps are doing database. Okay. Now I'm ignoring the offline job because I didn't want the screen to be too big. But for each, imagine a for each statement. For each deployable process in my release candidate, meaning for each unique NuGet file that has the same name and version number, i.e. is the same release candidate. One release candidate can have 4 NuGet files. It's the same release candidate, but there's 4 things to deploy. For each of those files, we need to get the package. We need to do some environment configuration, and then we need to put the files there. That's the deployment, okay? All right, so that's the database. The database has these 4 steps in the Azure Pipelines configuration. Next one is the UI, which is the ASP.NET web application. We need to deploy that web application to Azure App Service in this case. So we need to obtain UI package. We need to get the package, get the NuGet file. We need to do some environment configuration, which is really this next one. And then we need to copy the files there, which is UI deploy. And then because it's a web application, you have to do one more step, which is start the web application, start the website. Okay. All right. So that's what you have to do to get the website there. Now we start the concept of validation. And so we have a step called execute self-health check. That's just a PowerShell invoke HTTP request. Now, every time you deploy something, you want to ask it, are you running and are you healthy? And the software needs to be baked in the ability to answer that question. And so if we call a web service, if we call essentially an API controller on a web application, we should be able to ask it, are you running and are you healthy? Now, it can quickly, if it can answer back, are you running? Well, that's yes. But are you healthy? Well, we don't want it to just return a canned answer, because if it doesn't have the connection string to its database, and if it can't talk to its database or whatever other dependencies that it has, then it's not healthy. So you want to have and this is more elaborated in the book, you want to have a health check controller, which has just a couple lines of code to call out to each of the key dependencies just to make sure it gets a return call. before it passes back the answer, yes, I am healthy. And just a select top one record from your customer table or some very common table would be absolutely enough to make sure that you can do a round trip to your database. Or if you have a certain directory of files where you export PDFs to, make sure that that directory exists in that environment and that path is discoverable. So however many dependencies this particular deployed process has, you want to have just a few lines of code to tickle each dependency before you report back, I am healthy. Okay. Because it does us no good in Azure DevOps for this deployment to report back, I was successful, but then you pull up the software and it's completely broken, and you find, oh, it didn't actually deploy properly, because deploying properly means starting up properly. Okay. So we want this to check to see, hey, did you start up properly and are you healthy? And we don't want to have to burden, we don't have the logic of health as a part of our deployment configuration here. We want the deployed process itself to know how to self-evaluate what it means to be healthy. Okay. All right. After this self-health check, now we go and we're going to do more assertions, but now we have a test suite to deal with. But in order to deploy the test suite, we do our same pattern. Get the NuGet package, do a little bit of environment configuration, poking in configuration files and whatnot, and then asserting, well, we can run VS test and actually run that in-unit or X-unit library that's going to, in the web context, probably run some Selenium tests, which open up browsers and type in text boxes and click buttons, and actually run tests that exercise the fully deployed new build that we have. And then at the end of the TDD environment deployment configuration, we just run this process that deletes the resource group. Okay. All right, let's go on to the next one. Okay. I'm not going to talk in depth about the broad concept of defect removal in general, but Azure Repos has a fantastically implemented pull request process. And I strongly recommend that you make use of the pull request process. It's not that hard to implement. A few configurations, you want to look at the configuration and make sure that you mandate that all reviewer comments be addressed and that the integration build succeeds before allowing a pull request to be approved. And Capers-Jones has some findings in all of his studies and a recommendation about how to increase quality in a team setting. He found that there were 3 quality control techniques that, when put together, had a high correlation with overall delivered quality of a software team. The first one was testing in general, just different levels of testing. So if you're doing manual testing, unit testing, automated unit testing, automated integration testing, automated full system testing, you definitely got the testing covered. Then the next one was static code analysis. If you've put the Roslyn static analyzers in your integration build and are failing, if you have some rules that absolutely fail and you've got those in there, then that satisfies that and you're doing good there. The third one is formal inspections. And that is having the code and changes reviewed and taken through a formal inspection checklist. And the pull request implementation in Azure DevOps is perfect for the implementation of formal inspections. And so if any managers are on this call, go back to work and figure out how to create an inspection checklist. Start small. I mean, it could be things like every new change or every new class has a corresponding additional automated test of some sort. If we made a change to the code and we didn't add an additional test, well, that pull request should not be completed. That's a rule that I suggest, by the way. But whatever it is for your team, make a bullet list of things to check. Okay. And then when someone hits the approve button on that pull request, they're basically saying, hey, I went through the checklist. I made sure that this set of changes here complies with everything that we as a team said that we were going to be consistent with. And then that's it. It's not hard, but it has such a profound effect because we as a team could say we do all these things in a consistent way, but we don't. And we're stressed and we try to go fast or we forget. We just don't. But implementing inspections is going to increase your quality. And so I highly encourage you to enable pull requests and get your team an inspection checklist. Okay, so let's talk about the different classes of environments and what types of things that you should be doing with each of the classes of environments. Again, these are the classes of environments, and you need one of each. You need at least one of each in your DevOps pipeline. You can have as many of each as you want, but you need at least one of each. And in your test automation environment, yeah, you're gonna load static data and load test data. You're probably gonna recreate the environment from scratch, and you're gonna do lots of things. In a manual test environment, you're probably going to load static data, but you're not going to load all kinds of test data and user data. You're probably not going to recreate that environment every time because it would mess with manual testing scenarios. So you'd have some on-demand steps. And then definitely by the time you get to production, you're going to do less and less. Now, notice that running the health check is across every environment. You don't know that a deployment succeeded until you ask the application, hey, did you start up? Hey, are you healthy? Okay. Even if your application is an offline job of some sort, running an Azure Functions or web job or a Dapper sidecar app, or you need to ask it, hey, are you online? Are you running? And are you healthy? Are you happy? Because if any of those processes can't get to one of their dependencies, they're not happy. And the first time you run a transaction of a certain type, it's just going to blow up. So might as well know that it was a failed deployment, and don't let Azure DevOps lie to you and report back that it was a successful deployment if it wasn't. Okay. All right. So diving in a little bit more on these full system tests in the TDD environment and how to use Azure DevOps to the fullest. It's very common for web applications and even WPF and WinForms to use a tool to open up a screen, type in text boxes, click on buttons. Now, when you run this tool, and of course in the web sense, Selenium is really easy to, every time you do something, you want to capture what the screen looks like and then save it off as an image file. And Azure DevOps, the Azure Pipelines integration with the Azure test plans just keeps every one of those screenshots, and it's beautiful and it works simply. And every test, you'll be able to see the steps that go through. I'll zoom it in a little bit, and you can see this screen of this example web application. You see some text boxes, and you see the save button. Okay. Now, if this test fails at some sort, which the tests were designed to fail when we break it, and so this test will fail at some point. And as long as we have a screenshot, it's going to save us a whole lot of money with reproduction. We'll be able to see what the screen looked like, which will probably point us in the right direction. If we can't see what the screen looked like, all we know is, oh, the test failed. Well, when did it fail? Well, maybe we can go spelunk through the logs and see what line of code in the test method actually failed. And then, why did it fail? But if we have the screenshots, every step of the way, we're taking screenshots. We know exactly what happened. So I highly encourage you to use Azure DevOps in this way. It sounds so simple. Take screenshots and save them. Now, on every single build, every single deployment to the TDD environment, and every single acceptance test that's run in the TDD environment, keep every single image file. Yes, that's exactly what I mean. It will be a long time before you even think about the amount of image files that you want to save. And you know what? There's a solution for storage anyway. You only keep, the last some number of builds. If you don't care what happened over a month ago, okay, Azure DevOps will automatically clean that up for you. No big deal. But yes, you want as granular information as possible here. All right, let's talk about production telemetry that I push so much. Logs are important. Logs are great, but logs only get you so far. You also need to add to your telemetry tool belt. Logs don't actually give you the full picture. We often do software that equips and populates data warehouses so that our customers and our users can ask intelligent questions about the data and find trends. Well, we need to give ourselves that capability. The telemetry database needs to be our software engineering data warehouse that we can ask questions of to see how the software is behaving and what our users are doing. And so we need to add two concepts in addition to logs that probably most of you are familiar with. We need metrics and we need events. Metrics are numbers. Events are names and often include metrics. Now, let's look at our application again. Really, just simple application scenario here. Everybody has at least one of these. You have a web application, you have an offline job, you have a SQL Server database, you have a test suite. Every one of those should emit logs, metrics, and events to application insights. Okay, it works hand in hand with Azure DevOps. And if I go back to the view of the deployment, notice the first step, release annotation. This is actually telling application insights, hey, I am deploying version such and such of application such and such. Okay, we'll see that a little bit later. All right, web application, yep, needs to stream to the same instance of application insights. All of the deployed processes of a particular application need to push their data to the same instance of application insights. Now, log analytics, if you have VMs or if you have other legacy stuff, then you can aggregate all that stuff in log analytics. But if you have everything in Azure resources, then you might not even need log analytics and you can get everything you need from application insights. Okay. Now, just by enabling application insights, you get a lot of logs for free. And if you're using Entity Framework, if you're using SQL Server, there's so much that Application Insights knows because it knows about .NET. And so the actual logging of what query is being run, you get that for free just by enabling Application Insights. Now, when you add on, for example, custom events, well, now you can ask questions. Now you can create graphs and charts. Let me show you an example from a car auction application. Now, this was late last summer, and there are in this particular case was a new car auction application, and we can see a gradual increase in usage at the macro level, but also some seasonality because we have some dips where more auctions are done on the weekends than in the middle of the week. And so in this case, the application is emitting custom events that have names, okay? They have names, and you could probably guess that this application uses a CQRS pattern because these are named in the form of a command, which effectively is just wrapping up the intent of the user or the request of a user in the form of an object. And it's carrying object-oriented development all the way up to the user interface and packaging up what the user asked to do as an object and then carrying it forward. Okay, highly recommend that method, by the way. And so we can see different custom events, and we can choose some of them and graph them over time and see that, oh, we actually have an increase in, we can see which events we have an increase of and which events maybe stayed stable. It's one thing to say, oh, our requests per second or our overall requests went up. Okay, well, what does that mean? Did the transactions that we care about increase, or just general usage, some of which that we don't care about? Okay, these green boxes, these green check marks across the top are the annotations, the release annotations. For every one of the green box, that is a deployment to the environment that we have selected for this particular graph. So we can see if the point of a particular deployment to a production environment is to change some behavior or to cause some type of result, then we should be able to see that in our telemetry, in our graph. And so that's a mechanism to do it. So highly recommend you do that. When you hover over one of those green checkboxes, by the way, it gives you the direct link back to the deployment in Azure DevOps, along with a lot of information about that, the environment, the release number, the name, everything. So there's really, really good tight integration with Azure DevOps and application insights here. All right. I know that is a lot of information, but these are the things where there's tons of documentation about how to use this or that feature of Azure DevOps. But as more and more people have used it, some of the things are not obvious in the Microsoft documentation. And so these are some of the things that are really important to think about and do a certain way. Now, again, if you're expert level Azure DevOps, then you are fully equipped to choose how to do it. But if you're asking, how should I do it? I don't know how to quite evaluate the different methods or are even aware of the different possibilities, then I hope that this just gives you some easy rules of thumb so that you can fall into that pit of success. So as we wrap up, I'll just leave this on the screen so folks have my email address in case they wanted that free ebook.
Cool, thanks. Do we have any questions? Anybody have any questions out there? You can go ahead and post those in the chat window and we will grab them. I had a question. Do you know if Octopack has been updated for .NET Core yet?
Off the top of my head, I don't remember exactly how it was written. However, I know that I've personally assisted some teams that have Octopack running with .NET Core 3.1 applications. And I can't say definitively, but because Octopack is command line. Oh, wait, sorry. The answer to your question is yes, it has been updated. In MS Build, Octopack was a NuGet package. With .NET Core, Octopack is an exe command line tool. And so as you're running .NET.exe publish, all the files that need to get to an environment will be put in your published directory. And then you run octopack.exe, again, giving it that directory path, and it'll do its thing and produce your NuGet package. So yes, it's been updated with .NET Core.
Okay. Because we had a few issues with that and also with the multiple libraries in one project. So I didn't know if they had fixed that yet. Because we use Octopack for .NET Framework, and that worked beautifully for all our deployments, which was really nice.
Yeah, well, you're going to have to take Octopack out of that library because it doesn't work the same way. It's no longer a NuGet package that you add to the actual project. It's just an exe tool that you call command line now.
Gotcha. Do you know if there's plans on the Microsoft side to allow Visual Studio to attach to an existing pipeline?
To attach to an existing pipeline? You mean in order to edit and maintain the pipeline from within Visual Studio?
Right. So like normally it only allows you to create one. Every time you go in and say, hey, I want to select an existing one, it says, oh, it's already created. It doesn't create it for you. So we've built all of the pipeline out, but when we try to attach the project to it, we can't say, hey, I want you to build this pipeline when you check in. It wants to create a new one. I just find that really difficult or really frustrating that we can't attach to an existing pipeline that we've already taken the time to build. And also when we've created the pipeline from scratch, there's been problems in the on the other side, the deployment side of it, which we've had some issues with. So out of the box, it's not 100% ready to go.
Yeah, so I think that type of dependency relationship probably is common across a lot of products. And I'm thinking back to even 2005, where cruisecontrol.net had this big XML file, and every Git repository had to have its own cruisecontrol.net configuration. And if you had 5 applications, 5 Git repositories, you ended up having a similar structure because you wanted to mimic it, but you still had to duplicate and create 5 cruise control configurations, which was the definition of that pipeline. And so I think the same has been in Nant. The same has been in TeamCity. I think the same has been in Azure Pipelines. And so it's up to the organization to create consistency or some conventions across teams and across projects, because you are kind of having independent logic. Now, when it comes to the integration build, most of that logic ends up being stored in source control in whatever your build script is. Microsoft doesn't provide one, and that's unfortunate still, because over almost 2 decades now, the structure of a build file, or even in the 90s with C# a make file, the structure of those is actually a well-known pattern. And but Microsoft still doesn't provide one. And so too many users of Azure pipelines end up using all of those step templates and actually creating make file logic in Azure pipelines, and it's not maintainable that way. So in my book, I do give a template for a .NET Core build file in PowerShell format that can simplify that. Now, I will say, on the deployment side, every environment, unless you extract to step template libraries, every environment does duplicate logic, even if your intention is to have the same logic from the TDD environment to the UAT environment to the production environment. And on the small end, okay, that's a little paper cut. But as you rack up more environments and your application may have 2 or 3 offline jobs that you're deploying, and you may have a web application, but then you also have a API application, but now we also have a WebAssembly Blazor application, and it gets more complex. That's when a lot of Azure DevOps users kind of graduate from the release manager format and then augment the product with Octopus Deploy, which supports the more complex deployment scenarios and has a single deployment configuration for any number of environments and supports multi-tenancy out of the box, and really simplifies there, so you don't have as much duplication when it comes to deployment logic.
Yeah, so I started off with Octopus Deploy from the get-go.
Mm-hmm.
So I love it. And yeah, it definitely makes it simpler for more complex environments, and the same thing for every environment, which is great.
Yeah. I will say it's not an either or. Some people that are not familiar with either product, it's Octopus Deploy is just that deploy. Octopus Deploy is not a build server, does not have a build server in it, and does not run tests. It is awesome at all the deployment stuff and environment management and even maintaining your environments, but it is meant to be paired with a product that has a first-class build server. So that's why it's a really great pairing when you take Azure DevOps as your core and then augment it for deployments and environment management with Octopus.
Right. All right, I'm not seeing any other questions right now. If anybody has any questions for Jeffrey, go ahead and type them in the comments so he can answer those real quick. We'll give it another minute or so, and then we'll wrap up if we have no questions.
Awesome. I'm curious to know how many people are already using Azure DevOps significantly, or how many maybe just using it to trigger a compilation and still working on getting the full continuous integration steps. If anyone wants to throw into chat kind of what level of implementation they've achieved.
Yeah, we've been actually using Octopus Deploy in DevOps for 6 years now,
Nice.
fully. And before that, I wrote my own deployment system for databases using Redgate tools, and we had it all automated. And so I had a C# app that generated it specifically for how the DBAs in that company wanted to do it in the upper environments. We had it all automated lower environments with Redgate, but they had a more manual position for that. So, but yeah, I've been using it in my current company for over 6 years, and everything's automated. And I actually wrote a blog post about how much time it saved our company. And it's a significant amount of time over the past 5-6 years. I actually wrote that for Octopus Deploy a few months ago.
Okay. And there was one question that just popped up in the comments. How do we get the ebook? So if you look at the screen, screenshot it, just send me an email, and I'll get it out to you. And it's JEFFREY is the spelling.
I'm so used to my name. Sorry. It's the other way around.
Oh, you only published part of your name.
I know. I did. It's too long.
All right. Jeremy says, I'm using Azure DevOps for everything. CI/CD with multi-stage YAML pipelines. That's awesome. That's awesome.
Yeah. Have you used the Octopus Deploy online yet, or have you used just okay?
Yes, I have. In one scenario, it really became obvious that it was running in AWS, because in one scenario there was I think a rather large file that needed to be copied over to Azure, and moving that deployment to the cloud version of Octopus Deploy, I realized, oh, wait a minute, all that data is going from an AWS data center to an Azure data center, as opposed to within the same Azure data center where I didn't even notice the large file copy. So that is just something to keep in mind. If you're going to run your own Octopus server, okay, great, you can put it in the Azure region where you want it. If you're going to use the cloud version, it's going to run wherever, just like if you use Salesforce or anything else, it's going to run wherever they want it to run. However, registering a dedicated Octopus tentacle that lived in the Azure region, that allowed control over how the data flowed. So
yeah,
there's plenty of configurations to make sure that data doesn't have to go through the host. And a lot with firewalls, if you register your own agents with Octopus or register your own agents with Azure DevOps, you want to control the network topology. And so a lot of times you don't want any of that to go outside the local firewall within a certain Azure region. And there's plenty of knobs to control that.
Yeah, for us, we have Azure DevOps in the outside and dumps to Octopus Deploy local repository, and then we have all of our servers in house, and it does all that deploying there. So it stays all in internal network once it's deployed here or pushed here.
Sweet.
Cool. All right. Well, I'm not seeing any more questions. Thanks, Jeffrey, for coming out and speaking for us tonight. Appreciate that. And I look forward to checking out your book there and see if I can learn anything new or do something I haven't quite done yet.
Awesome. Well, thanks for having me to present, and it's my pleasure.
Awesome. Thanks.
Ending
See everybody next
broadcast.
month.